All right, today we're looking at solving systems by graphing. So we've looked at the graphing calculators in our solutions. We have also looked at our doing some of the equations and just graphing them and looking at that point of intersection. So again, today we are going to be looking at two or more linear equations is what we have for a system when we are looking at a system of equations, linear equations. And as we look at that system of linear equations, the ordered pairs of all the equations is what makes it true. So when we think about our solution always has to be written as an ordered pair x, y. Okay? So we are looking at that point of intersection on our graphs. And the x, remember, is what moves left and right, and the y coordinate moves up and down as we are looking at those. So here we have, similar to some of the problems we did last week and with our graphing calculators, we are looking for, as we look at each equation, we always want to be thinking what is our y-intercept and what is our slope. So in this one, our start point is going to be at 0, 2, that's our y-intercept, and our slope is actually 1 over 1. Remember that we always write it as a fraction. So we're going to start up at positive 2. Our slope is 1, which means we're going to rise 1 and run 1, and we're going to continue doing that. We kind of want to fill the whole graph so that when we go to draw our line, we can see actually where that point of intersection is. So once we have that, we now want to draw a line. And I would suggest using a straight edge. Some of you, if you don't use a straight edge, you're not going to get exactly a straight line. As we look at this next equation, I'm going to graph this one with green. As we are looking, what is our y-intercept? Well, remember, this is plus a negative 2, so we have 0, negative 2. That means we're starting on the y-axis, not on the x. It's not called the x-intercept, it's called the y, because it's on the y line, negative 2. And here our slope is actually 3 over 1. So when we look at 3 over 1, that means to rise 3 and run 1. And so far it looks, if we continue this pattern, we are going to intersect right at this point. So we are now looking for that point of intersection. You need to draw both lines. So as we are looking at that, we want to draw our line. And again, when we draw these lines have arrows on the end. They are not segments, they are lines. They continue. We could have continued this one down even further here. And the question is, what is our point of intersection? Our point of intersection is going over from our origin 2 and up 1, 2, 3, 4. So we're going to write that as 2 4s in ordered pair. X, Y. Always X, Y, alphabetic order. Now, the question is, when you look at these, did we do it right? So how could we check it? I know you guys love doing this, but remember, we just said x was 2 and y was 4. So we're going to go back to the original equation, the original two equations, okay? The first one was that y equaled x plus 2. Well, we said y has to be equal to 2 plus 2. Check. Looking at our second equation, we said y needs to be equal to 3x minus 2. Always go back to the original. And is it true, the question is 4 equal to 3 times 2 minus 2, 6 minus 2? Check, and you are done. Now, sometimes they're going to have you write from situations into the problems. You're not going to have as many of those to do tonight. You're mostly going to be looking at solving the equation with finding the one solution, or you might find no solution, as we talked about, or infinitely many. So the first thing is we look at this situation. It says scientists studied the weights of 2 alligators over a period of 12 months. The initial weight and growth rate of the alligators is shown. About how many months did the alligator weigh the same amount? Well, look at our first one. It started at 4 pounds and it's growing 1.5 per month. Per is helping us find our, that goes with our slope. The second one started at 6 pounds and is growing by 1 pound per month. So what are our variables that we are looking at in this situation? Our variables actually are going to be the weight of the alligator. That's our y. So y is the weight of the alligator. And our x is going to be the number of months until those two alligators are equal in weight. So x is equal to the number of months. If I was going to ask you to write an equation, remember, we're going to think about our linear ones. Y equals, the weight is, started out at 4, growing at 1.5. 1.5 is our rate of change. That's our slope. Per month, that's our x, plus, in this case, 4. Our second equation, y equals, this one is growing at 1 a month, 1 pound a month, plus 6. Now, I want you to realize that if we were going to graph this, we need to find our point of intersection. And here it might be a little harder to graph 1.5. So we might have even rewritten this equation as y equals 1.5 is actually 3 over 2x plus 4. Because we know how to graph when we are looking at that with the slope and y-intercept. Here's what the graph looks like, and I'm going to show this to you because I actually want you to just look at this, but we actually don't want to, I want you to look at this graph. And notice that the scale that they used, here they went up by 2s, here they went up by 1s, and they found this point. Now, this is not the easiest way to find the solution because it's kind of ugly. So we are going to look in the next week and later at a couple other ways. Here, the main thing I want you to be able to do is to write the equations. So when we look at this example, what we are looking at, it says one satellite radio station charges $10 per month. Are we thinking slope or y-intercept with the word per? Hopefully slope. Plus an activation fee of $20. That is our initial fee, right? That's our y-intercept. A second company charges $11 per month. And again, this is our, with the word per, our rate of change, our slope. Activation fee of $15. And if we are looking at those two companies, now this one we definitely are not going to graph because the numbers come out really kind of ugly. We're going to look at y sub 1 for company 1 and y sub 2 for company 2. In the first one, we said it's $10 per month. So pause the video right now and see if you guys can write this. Write the equation for y1 and for y2. After you've paused the video, so you'll pause it now, it'll come back on and you will then see your solution. 10x plus 20, 11x plus 15. And again, this one we are not going to graph. But on this next page, there's kind of some very important notes. And again, as you are watching this, I want you to read through the 3 different possibilities because they're pretty important when we look at these different possibilities. The first one is when we look at 3 possible outcomes is parallel lines. What happens when we have parallel lines? They never intersect. It's no solution. So down here is an example of parallel. The second case that we have is when we have intersecting lines, and that's what we've been doing for most of ours, where you have one solution. That one point is our point of solution, so I have one solution. The last type that we could have, this is called a, if we are looking at it, it's when you get the same line. The equations come out exactly the same. It doesn't happen that often, but there's a few of them. And that's when there are infinitely many solutions. So just like when we were solving before, we have one solution, infinitely many solutions, and no solution as we are looking at our graphs. So make sure you read through this page rather carefully as you are looking at it. We now are going to try 2 more cases, and then you're going to have time to work on your homework. And again, in both cases, one of the first things you need to make sure is that your equation is written in slope-intercept form. Here we have it in slope-intercept form, and our second one is not. What do we have to do to get it in slope-intercept form? Subtract the x. Y equals, and instead of putting 5 first, we're going to write it as negative x plus 5. So we now have these 2 equations. I want you to graph those. What I'm going to do is I'm going to rewrite this equation. Again, you're going to graph these 2, so pause the video. We'll check your solution in class. If we look at this second one, we are now going to have adding an x to both sides. You'd have 2y is equal to, and I'm going to put a 1 in front of my x, plus 2. I'm still not done solving for y in that first equation, so I'm going to divide everything by 2. So my new first equation is going to be y equals 1/2 x plus 1. And what you should be noticing at this point is this is exactly the same as this second one. So we're going to graph both of these. I'll pause the video. You should do the same and make sure you plot yours. All right, so after you've paused the video, you can now see we graphed the first two equations and they're exactly parallel. They have the same slope of -x but different y-intercepts. One's down at -3, one's at a +5. Parallel lines. What happened in that second equation is when I graphed y equals 1x plus 1/2, I started at 1, slope of 1/2. The other line went right on top of it. So I have infinitely many solutions here. Infinitely many solutions because every point on the line is going to be a solution. And then in the other one over here, there is no solution because these two lines will never intersect. They have the same slope. So your worksheet that you're going to be working with, you're asked to do some questions. And then as you are doing that, you are going to be solving the equations. So good luck and